Hi students, how are you all? This is Shravanti, you are watching Maths for You. So I am uploading some videos on ring theory which are helpful for BSc and MSc or for higher education. So we have discussed already 2 lectures of ring theory. So the first lecture is about the ring and its examples, and the second lecture is about some zero divisors. So now here the present definition is about integral domain. So before going to know about the integral domain definition, so we have to revise already previous lectures, the first and 2. What are that? So I want to revise the thing. So now in the ring definition we have discussed the 2 topics, that is types of ring. What is that? Ring with unity and commutative ring, right? So this is our first thing which we have to know, and the second thing is zero divisors. So zero divisors with zero and without zero divisors. So now let me tell you something that, so any given R or Z or any, let us take D, non-empty set D, that D is said to be integral domain, so it should satisfy some conditions. So now I want to revise that. What is a ring? Just a small revision for that. Ring means it should satisfy some 3 conditions, that is R comma plus to be abelian group and semi-group and distributive laws. And ring with unity means the identity element should be exist. Commutative means what? The multiplication is commutative. And zero divisors with the zero divisors without zero divisors. With the zero divisors means what? If you are taking 2 non-zero elements, what happened? The product should be equal to 0. So without zero divisors means which? The product should be equal to 0. Either A equal to 0 or B equal to 0. So this is the preview of what we have discussed in the earlier videos. So ఏం చెప్తున్నానంటే, మనం ఇంటిగ్రల్ డొమైన్ రావాలి అంటే కనుక ఏం చేయాలి? మనకు ఫస్ట్ రింగ్ అంటే ఏంటో తెలియాలి. రింగ్లో టైప్స్ ఆఫ్ రింగ్స్ అంటే రింగ్ విత్ యూనిటీ ఏంటి, కమ్యుటేటివ్ రింగ్ అంటే ఏంటి, జీరో డివైజెస్ అంటే ఏంటో తెలియాలి. అంటే ఇంటిగ్రల్ డొమైన్ కావాలి అంటే ఫస్ట్ ఇవి 2 తెలియాలి. ఆల్రెడీ ఈ 2 గురించి మనం 2 వీడియోస్లో చాలా వరకు డిస్కస్ చేసుకున్నాము క్లియర్గా. బట్ ఇప్పుడు ఓవర్లుక్ అనమాట, ఏంటి ఎట్లా అన్నది. రింగ్ విత్ యూనిటీ అంటే ఏంటి? ఐడెంటిటీ ఎలిమెంట్ ఎగ్జిస్ట్ అవ్వడం. కమ్యుటేటివ్ అంటే మల్టిప్లికేషన్ ఇస్ కమ్యుటేటివ్ అవ్వడం. అంటే ఏంటి? కమ్యుటేటివ్ అంటే ఏంటిది? ఏబి ఈక్వల్ టు బిఏ. అందులో కాంపోజిషన్ ఏం కావాలి? మల్టిప్లికేషన్ కావాలి. అట్లా జీరో డివైజెస్ కూడా మీకు ఎన్ని టైప్స్ ఉన్నాయి? విత్ జీరో అండ్ వితౌట్ జీరో. సో ఇవేంటి? 2 కండిషన్స్. ఈ విధంగా రింగ్ అంటే ఏంటో ఈ 2 తెలవడం, జీరో డివైజెస్ ఇదంతా తెలిస్తే అప్పుడు ఇంటిగ్రల్ డొమైన్ తెలవడం అంటే చాలా ఈజీ. సో నా వాట్ ఐఎమ్ టెలింగ్ ఈజ్ దాట్, సో integral domain is nothing but you have to know about ring and zero divisors perfectly. So now if R is a ring and it is a ring with unity and it is commutative, then what you can say that ring is a commutative ring with unity. Given any non-empty set, it should satisfy some conditions, then it is ring. If it satisfies ring with unity, it is ring with unity. If satisfy commutative, then it is commutative. Then overall what you can say? Commutative ring with unity. Then if has with or without zero divisors, then you can say commutative ring with unity with or without zero divisors. So now what I want to tell you is that, so integral domain is nothing but the ring means it should satisfy the properties of ring. The ring R is nothing but it should commutative ring with unity, commutative ring with unity without zero divisors. What is the thing should happen here? What zero divisors? Without zero divisors, then that ring or that is known as a integral domain. Without zero divisors means what? AB equal to 0, either A equal to 0 or B equal to 0. Then you can say that given ring or given D non-empty set is an integral domain. Let us see an example here. So now let us take Z only. So because we are taking on Z only, then it will be easy clear for you. So ఇప్పుడు ఏంటి ఇంటిగ్రల్ డొమైన్ అంటే ఏం కావాలి అంట? కమ్యుటేటివ్, రింగ్ విత్ యూనిటీ అండ్ వితౌట్ జీరో డివైజెస్. ఈ 3 ప్రాపర్టీస్ కనుక సాటిస్ఫై అయినట్టయితే అది ఇచ్చిన రింగ్ ఏదైతే ఉందో అది ఇంటిగ్రల్ డొమైన్ అని అంటారు. సో ఈ విధంగా దిస్ ఈజ్ అ కమ్యుటేటివ్ రింగ్ విత్ యూనిటీ వితౌట్ జీరో డివైజెస్. వితౌట్ జీరో డివైజెస్ అంటే ఇది కండిషన్. మనకి ప్రోడక్ట్ ఈక్వల్ టు జీరో అయితే ఏదో ఒకటి రెండిట్లో ఏదో ఒకటి ఏం కావాలి, మనకి జీరో కావాలి, ఇంకొకటి నాన్ జీరో కావాలి, అంతే కదా. ఐదర్ ఆర్ అంటే అదే కదా, ఏదో ఒకటి అన్నట్టు. సో ఆ విధంగా మీకు ఇట్లా ఈ ప్రాపర్టీతో పాటు ఇది కూడా అయినట్టయితే దెన్ యూ కెన్ సే దట్ ఆ ఇచ్చింది మీకు ఇంటిగ్రల్ డొమైన్ అవుతుంది. సో ఎగ్జాంపుల్ Z చూద్దాము. ఎందుకంటే Z comma plus comma dot, because from the previous lectures we are discussing only about the Z. So it is very easy. Then you can differentiate how it happens. So now let us take ring Z. First we can say it is a ring. How you can conclude it is a ring? Because let's clean it. So you can say that Z is a ring. How? Already we have discussed in the first, like what is that? Z comma plus should be abelian group. Z comma plus is abelian group. Z comma dot is semi group, and it should satisfy some distributive laws, that is left and right distributive law, and right distributive law. If Z satisfies these 3 conditions, then you are concluding that Z comma plus comma dot is a ring. Got my point? So నేనేం చెప్తున్నాను, ఇచ్చిన Z comma plus comma dot రింగ్ కావాలి అంటే Z with ఆపరేషన్ ప్లస్ అబిలియన్ గ్రూప్ కావాలి. మళ్ళీ అబిలియన్ అంటే 5 ప్రాపర్టీస్: క్లోజర్, అడిటివ్, క్లోజర్ ప్రాపర్టీ, ఐడెంటిటీ, ఇన్వర్స్ అండ్ కమ్యుటేటివ్, అసోసియేటివ్, రైట్. అదైతే ఏమవుతుంది, Z comma plus is an abelian group. With respect to the operation, that is composition, multiplication, should be semi group, means associative. Then distributive, right and left distributive laws. So if it satisfies 3 conditions, then it is a ring. And already we also know that Z is ring with unity. Z is ring with unity and it is commutative ring. That is commutative ring. Ring with unity, how you can say that? As it is an integer, Z is nothing but the set of integers, 0 plus or comma 1 plus or comma 2, and so this is an integer. So ring with unity means you have to get the identity element. Multiplicative identity, here you are getting 1 belongs to Z. The multiplicative identity, always in the multiplication the identity element is 1. So ring with unity means you have to exist the multiplicative identity. So the multiplicative identity is exist in Z, then it is ring with unity. And the commutative property is also, that is commutative is multiplicative. Already we have discussed all these things, but if you have a clear picture about Z only, then you can say that whether it is integral domain or not. Already మనం ఇదంతా కూడా ప్రీవియస్ 2 లెక్చర్స్ లో డిస్కస్ చేసుకున్నాము. బట్ ఇదంతా తెలిస్తేనే రింగ్ అవుతుందా, ఇది అవుతుందా, అయితేనే ఇంటిగ్రల్ డొమైన్ ఎట్లా అవుతుంది అని చెప్పడానికి ప్రాబ్లమ్స్ లో అయినా కానీ ఇక్కడైనా మీకు క్లియర్ గా ఉంటుంది. సో నౌ లెట్స్ సీ, ఇఫ్ యు టేక్ 2 elements 1, 2 equal to 2, 1. So up to here what happened? Up to here Z is a commutative ring with unity. Up to here Z has become ring, and these both, then it is a commutative ring with unity. Then next, what is the property to show it is an integral domain? The other thing is you have to show without 0 divisors. That is, you have to take the product equal to 0. Then obviously you can take 0, 1 equal to 0, right? That is AB equal to 0. Here what happens? Either A equal to 0 or B equal to 1. That is right. So any of one is a 0 element, right? So then you can say that it is without 0 divisors. Without 0 divisors. So it has happened that it is a ring. It is a commutative ring with unity, and it is without 0 divisors. Then the conclusion is that Z with respect to the composition plus and dot is an integral domain. So in this way you have to check whether the given set or any non-empty set it becomes an integral domain or not. So you have to check in this way. So already this is an abelian group you have. Please go to, if you have any doubt whether it is a ring or not, please go to my lecture 1. It is very clear how I have proved whether it is a ring or not. So this is also there. So up to here you can check in my first video, and up to here this is your second video. So by first and second you can conclude that without zero divisors then it is a ring. Let's see another example which will be very clear for you. Now let's see just definition. Integral domain, and a ring D is said to be integral domain if it is commutative, ring with unity and without zero divisors. The example is Z. So similarly you can say that Q, R and C are also integral domains. How means always the Z is a subset of Q, and Q is a subset of R, and R is a subset of Q. See, they all are subsets. So now if Z is becoming the integral domain, then these are also similarly, as it is a subset, this is an integral domain, this is an integral domain, this is an integral domain. So in this way, so Z, R, Q, R, C all our becomes an integral domain. Let's say another example of Z3, right? Now let us see the example of Z3. So here the ring given. So now Z3 equal to how many elements? 3 elements. Under addition and multiplication is an integral domain or not. So he is saying that integral domain. So now we have to check it is integral domain or not. For that I have taken the composition tables under the addition modulo 3 and multiplication modulo 3. So see here addition modulo. So we have to place the two elements, 0 plus 0, that is 0 plus 1, 1, 0 plus 2, it is 2. So 0, 1, if you are getting 1 into 1, it is 2. So 1 plus 2 is 3, under addition modulo 3 it becomes 0. So 1 into 2, this is 2 plus 1, it is becomes 3, under addition modulo 3 it becomes 0, right? So now 2 plus 2, 4 under addition modulo 3 it becomes 1. So multiplication, if you multiply with 0 every element becomes 0. If you multiply with 0 these are the no, you can eliminate this. For any multiplication you can take only the non-zero elements, it is will be better. So now 1 1s are 1, 1 2s are 2. So 2 1s are 2, 2 2s are 4, but under multiplication 3 it becomes 3, 2 4 it becomes under 3 it is 1, right? Ante kada 4 amma under multiplication it becomes 1. So now what we have to check here, now we have to check whether it is a ring or not, right? So for that already here given ring, but if it is not given ring you have to check the ring condition. So let us take this is Z3, right? So now to check it is whether a ring or not, there are some conditions. Let us take this is table 1 and this is table 2. So from first table, from table 1 I am saying that Z comma plus is an abelian group. Is an abelian group. How you can say that? Abelian group means the closure property, every element 0 comma 1 2 is belonging to that set only Z3, and associated if you take any two elements, if you multiply with another element then LHS equal to RHS. Identity element with respect to plus 3, the additive element is 0, so you are getting every element is 0, and the multiplicative, that is nothing but inverse element, the inverse is also existing for every element here. The next is abelian, that is commutative property, AB equal to B. If you take 1 into 2 then it becomes 2, 1 plus 2 under addition modulo 1 plus 2 it is 3 and 2 plus 1. So I am saying that Z plus is an abelian group. In the first table it is the clear picture. And what is the second property of ring? What is the second property of ring? Semi group. So now we have to consider from the second table Z comma dot is a semi group. Semi group is nothing but the association under multiplication, right? Now you can say that here if you take any two elements and multiply with another element then LHS equal to RHS, the associative property is also satisfied. So now what you can distributive law is also satisfied. So now distributive, it is very clear, distributive laws, it is very clear that Z3 is a ring. Up to here you can say that Z3 is a ring. So how to do step by step, please check my first video. Then it is a very long process if you do the every property here. So now you can say that Z3 is a ring. And what more to prove that integral domain? What is the next? Ring with unity and next commutative ring. Ring with unity means what? You have to check the multiplicative identity. So always the multiplicative identity will be checking in the second multiplicating table. Here one is for every element, the identity is Bigolling. So then you can say that one belongs to Z3. So multiplicative identity is exist. Multiplicative identity exists. So therefore you can say that it is already a ring. You are getting unity here, therefore it is ring with unity. Got the point? So now we have proved it is ring and we have proved that every multiplicative identity is exist here. Multiplicative identity has exist here. So next commutative, you can take any commutative 1 into 1, then you get 1 into 2 or 2 into 1, you becomes only 2, right? So now that is commutative is satisfied. Under multiplication, under commutative, under multiplication, that is what? A into B equal to B into A. You can say that 1 into 2 equal to 2 into 1. So this is so up to here what you can say that it is a commutative ring with unity. It is commutative ring with unity. So now Z3 is ring. It is ring with unity and it is commutative. Then totally Z3 is commutative ring with unity. So now have you got the point? Ring with unity means the multiplicative identity should be exist. The commutative under multiplication means in this way you have to prove. So next what you have to prove? Without zero divisors. You have to prove without zero divisors. So always remember, this is very important point for everyone. Please students, multiplicative identity, it is exist, it is clear, it can be checked. Multiplicative means under the table 2 only, multiplication modulo. So if you are taking the commutative is multiplicative, it is also checked in the table 3, but always the without zero divisors happens in the multiplicative. Without zero divisors or zero divisors always happens in the multiplication. Got the point? So eppudaina gaani zero divisors, it happens only in the multiplication. So now what you have to check, whether that is, let us take what is the condition. If A cross B equal to 0, either A equal to 0 or B equal to 0. So now you can check here you, if you are taking two any non-zero elements, you are getting 0. If you are taking any two non-zero elements, you have any one is 0. If A is 0, B is 1, you are getting. So if you are checking for, if you want to check for a non-zero elements, so you see here for this table only you are getting only 4 elements. For any two non-zero elements, you are getting a non-zero element. For any two non-zero elements, you are getting non-zero elements. So no identity, that is 0 is existing. So then you can also say that it is without zero divisors. Got the point? You are checking here, you have only 4 points. There is no zero element, that is no zero element has exist in this table of this 4. Then you can say that it is a without zero divisors. So then in this way you have to conclude that Z3 comma plus 3 is an integral domain. So once again I will tell you. సో మీరు ఏం ప్రూవ్ చేయాలి? Z3 అనేది ఇంటిగ్రల్ డొమైన్ అని ప్రూవ్ చేయాలి. దానికోసం కాంపోజిషన్ టేబుల్స్ 2 అడిషన్ మోడ్లో మల్టిప్లికేషన్ మోడ్లో తీసుకోవాలి. రింగ్ అని ఇస్తే అవసరం లేదు, రింగ్ అని ఇవ్వకపోతే రింగ్ అని ప్రూవ్ చేయాలి. రింగ్ అని ప్రూవ్ చేయడం కోసం మనకి 3 కండిషన్స్ ఉంటాయి: అబిలియన్ గ్రూప్, సెమీ గ్రూప్, డిస్ట్రిబ్యూటివ్ లాస్. సో మనకి అబిలియన్ అయిపోతుంది, సెమీ గ్రూప్ అవుతుంది, డిస్ట్రిబ్యూటివ్ అవుతుంది. సో ఎట్లా చెక్ చేయాలి స్టెప్ బై స్టెప్ అంటే మీరు ఫస్ట్ వీడియో చూడండి, దెన్ ఇట్ విల్ బి క్లియర్ హౌ టు చెక్. సో ఎందుకంటే అన్ని 4-5 ప్రాపర్టీస్ అయిపోతుంది, సెమీ గ్రూప్ అసోసియేటివ్ అండర్ మల్టిప్లికేషన్ అయిపోతుంది. నెక్స్ట్ రింగ్ విత్ యూనిటీ చూడించాలి అన్నందుకు Z3 కాబట్టి మనకి ఇక్కడ మల్టిప్లికేటివ్ ఐడెంటిటీ ఎగ్జిస్ట్ అయిపోయింది ఆల్రెడీ. సో Z3 అండర్ మల్టిప్లికేషన్ కాబట్టి ఇక్కడే చూసుకోండి, ఫర్ ఎవ్రీ ఎలిమెంట్ హియర్ యూ ఆర్ గెటింగ్ మల్టిప్లికేటివ్ ఐడెంటిటీ కాబట్టి రింగ్ విత్ యూనిటీ అయిపోయింది. సో నెక్స్ట్ కమ్యూటేటివ్ కూడా అవుతుంది, AB ఈక్వల్ టు B. ఇఫ్ యూర్ టేకింగ్ 1 into 2 then 2 into 1 it becomes only 2, right? బికమ్స్ ఓన్లీ 2. సో ఈ విధంగా మీకు ఏమైపోయింది, రింగ్ అయిపోయింది, కమ్యూటేటివ్ రింగ్ విత్ యూనిటీ అయిపోయింది. సో నెక్స్ట్ ఇంకేంటి ప్రూవ్ చేయాల్సింది, వితౌట్ జీరో డివైజెస్. కాబట్టి వితౌట్ జీరో డివైజెస్ అంటే ఇఫ్ యూర్ గెటింగ్ ద ప్రోడక్ట్ ఈక్వల్ టు 0 either A or B equal to 0. సో ఇన్ ద టేబుల్ if you are eliminating this 0 column, 0 divisors, then for this non-zero elements you can check for every 2 non-zero elements you are getting, అంటే no zero divisor is existing here, then you can say that it is a without zero divisors. If you go by the definition, if you are taking 1 into 0 into 1 it becomes 0, 0 into 2 it becomes 0. So in this way also you can check, or for any in the table, by looking the table you can simply say that where no zero element is existing, so therefore it is without zero divisors. So in this way you are going to prove how an integral domain exists. So this is the example, so which is very useful I think for you. So in the next video, upcoming video, that is let us take some Z3, Z4, Z5, Z6 like that. So under addition and multiplication and modulos, so let's check whether which Z3 or Z4 is becoming integral domain with or without zero divisors. Got the point? In the next upcoming videos, let us check Z3, Z4, Z5 and Z6. Let us take these all things and let us check these are becomes already, this becomes ring, it's not a problem. So now we will check that these are integral domains or not, and whether they are integral domain with zero divisors or without zero divisors, which will be helpful you very. So next, this is your upcoming video. I think it is very helpful for you. So this is the concept of integral domain with the example. So if you are any doubts, you can comment me. So thank you for watching my video. Please share and subscribe.